The world is getting hotter. That's a fact. So how could one of the most populated continents on Earth be heading for a dangerous deep freeze? This isn't science fiction. It's a real, unsettling possibility. The answer lies not in the sky, but deep in the Atlantic Ocean. It's a story about a vast, planetary-scale conveyor belt that has acted as Europe's central heating for thousands of years. And we may be breaking it. It's called the Atlantic Meridional Overturning Circulation, or AMOC for short. Forget rivers on land. This is a colossal river within the ocean, circulating water between the tropics and the far North Atlantic. And when I say colossal, I mean it. At its peak, it moves nearly 100 times more water than all the world's rivers combined. It is the single largest movement of heat and water on the planet. Now, you've probably heard of the Gulf Stream. It's famous for carrying warm water up the American coast, but thinking the Gulf Stream is the whole story is like thinking a single spark plug is a car engine. The Gulf Stream is just one part. The AMOC is the entire supersystem. This system transports an incredible amount of warm, tropical water northwards. As it travels, it releases heat into the atmosphere, which the prevailing winds then carry over Europe, acting like a giant continental radiator. This is why London is famously mild and rainy, while cities at the same latitude, like Calgary, Canada, endure frigid, snowy winters. They receive the same amount of sun, but Europe gets a massive hot water bottle delivered by the AMOC. But for the conveyor belt to keep moving, the water needs a return path. After releasing its heat to Europe, the water becomes cold and therefore denser. This is the overturning part of the name. The cold, heavy water sinks deep into the ocean. This sinking acts like a giant plunger, pulling more warm surface water up from the tropics to replace it. It's a pull, not a push. This deep water formation in the North Atlantic is the sensitive, vital engine of the whole system. This deep, cold water then begins a slow journey back south, a creeping, dark river along the ocean floor. It can take up to 1,000 years for it to resurface in the south, warm up, and begin the journey all over again. So what makes this engine so powerful? It's driven by two simple principles of density. First, as we've said, cold water is denser than warm water. But there's a second, even more crucial factor. Salt. Salty water is significantly denser than fresh water. It's packed with more stuff. So cold, salty water is the heaviest of all, and it desperately wants to sink to the bottom of the ocean. And here's the final piece of the engine. As the warm water travels north from the tropics, some of it evaporates, but the salt gets left behind. This means the remaining water gets progressively saltier and colder. It's the perfect recipe for sinking. Cold plus salty equals sinking. That's the formula that has driven Europe's stable climate for millennia. A reliable, powerful, ocean-spanning engine. So, what happens when we sabotage the recipe? Here's the wrench in the works. A very big, very cold, very fresh wrench. As the planet warms, the massive ice sheet on Greenland is melting at an unprecedented rate. We're talking about billions of tons of ice lost every year. That's thousands of tons of fresh water pouring into the North Atlantic every single second. And this water is the AMOC's kryptonite. Remember our density rules? Freshwater is much less dense than saltwater. It's lighter, it likes to float on top. This creates a stable lid of fresh water on the surface of the North Atlantic. It prevents the salty water below from making contact with the cold winter air, so it doesn't cool down enough. It effectively insulates the deep ocean. It also dilutes the saltiness of the surface water. It's like adding a huge amount of fresh water to a thick, salty soup. The soup gets thinner, less dense, it loses its weight, so the perfect recipe is broken. The water is no longer cold enough or salty enough to sink. The engine sputters. The sinking weakens. And if the sinking in the north weakens, the pull on the surface water from the south weakens too. The whole conveyor belt starts to slow down. The central heating gets turned down. This isn't just a future projection. Based on multiple lines of evidence, the scientific consensus is that the AMOC is currently at its weakest point in at least 1,600 years. The slowdown is already happening. How do we know? By reading the ocean's memory. Scientists drill deep into the ocean floor, pulling up long cores of sediment. These layers of mud are like tree rings, recording millennia of ocean history. They look at the size of the sediment grains. A fast, strong current can carry larger, heavier grains. A weak, slow current allows fine, light mud to settle. By analyzing the grain size, they can reconstruct the speed of the AMOC over centuries. The big fear isn't just a gradual slowdown. It's a tipping point, a threshold beyond which the system doesn't just weaken, but rapidly collapses into a new, stable, but much weaker state. Think of leaning back in a chair. You can lean, and you're fine. But go 1 millimeter too far, and the change is abrupt and irreversible. You can't unfall. Scientists are racing to figure out where the AMOC's tipping point is. One controversial 2023 study made headlines by suggesting this tipping point could be reached with 95% certainty between 2025 and 2095. Now, before you panic, it's crucial to state that this is not the consensus view. Many scientists criticized its methods. Most major climate models, like those used by the IPCC, suggest a full collapse isn't likely this century. But they all agree the risk is real and the AMOC will continue to weaken. The debate is about the timing and nature of the change. A slowdown is like your car's engine running rough. A collapse is the engine seizing completely. We are time a slowdown. The debate is how close we are to a full collapse. So let's run the thought experiment. Let's take the worst case scenario. What would actually happen if the AMOC engine did seize up and collapse? First, let's be clear. We are not talking about the movie The Day After Tomorrow. Europe would not flash freeze overnight. The underlying global warming is still happening. This wouldn't trigger a new global ice age, but Europe would experience a dramatic and rapid cooling, likely over just a few decades. Average winter temperatures could drop by 5 to 10 degrees Celsius, or even more in parts of Scandinavia and the UK. This would effectively give London the climate of Reykjavik in Iceland. It would make winters in Paris feel like winters in Poland. It would be a fundamental shock to the system. It wouldn't just be colder. The massive temperature difference between the newly cold Arctic and the still warm tropics would create a huge atmospheric pressure gradient. This could supercharge the jet stream, leading to more frequent and violent winter storms battering Europe. Agriculture would be devastated. The growing season would shorten dramatically. Crops that define entire regions, wheat in France, vineyards in Italy, potatoes in Ireland, would fail. This would lead to widespread food shortages and soaring prices, not just in Europe, but globally. And the effects would be global. Paradoxically, while Europe freezes, the US East Coast could see accelerated sea level rise. Right now, the AMOC's strong pull piles up water in the eastern Atlantic. If you turn off that pull, the water would slosh back, potentially raising sea levels from Boston to Miami by 0.5 meter or more, on top of existing sea level rise. The band of tropical rainfall, which is tied to the ocean's heat balance, would likely shift south. This could cause severe and persistent droughts in West Africa, threatening the food security of hundreds of millions, while causing massive flooding in places like Brazil. The consequences extend far beyond just needing a warmer coat. Colder, longer winters would cause a massive surge in energy demand for heating, putting unprecedented strain on power grids not built for that load. Much of Europe's infrastructure, from water pipes to railways, simply isn't designed for sustained deep freeze conditions. We could see widespread failures, and even sea ice closing major ports in the UK or France. And then there's food. A collapse in European agriculture wouldn't just mean local shortages. It would send shockwaves through the global food supply, causing price spikes and scarcity thousands of miles away. Such a profound economic and agricultural shock could even trigger large-scale migration, as people are forced to move from regions that have become economically devastated or simply too difficult to live in. And the effects ripple outwards. A weaker AMOC could shift tropical rain belts, potentially triggering severe droughts in parts of West Africa and South America that rely on that predictable rainfall. Perhaps the greatest danger isn't a predictable slide into a colder world, but the loss of predictability itself. A chaotic climate with more violent swings between extremes would make planning for the future almost impossible. While a total, immediate collapse remains a worst-case scenario, not a certainty, the evidence shows the system is becoming less stable. The question scientists are racing to answer is, how close are we to a point of no return? So let's recap the chain of events. A warming planet melts Greenland's ice. This pours fresh water into the North Atlantic, diluting the salt and creating a lid on the ocean. This prevents the cold, salty water from sinking, which weakens the engine of the AMOC. A weaker AMOC means less heat transport to Europe, causing regional cooling, agricultural chaos, and more extreme weather. And the effects ripple outwards, impacting sea levels and rainfall patterns across the globe. This brings us to the most important point. The true danger of climate change isn't just that everywhere gets a bit warmer, it's that we are pushing ancient, powerful, and delicately balanced systems like the AMOC towards tipping points. And we don't know exactly where they are. We're trading a predictable world for an unpredictable one. The AMOC is just one of many climate tipping points scientists are worried about. What other hidden systems that run our world should we explore next? Let us know in the comments. And if you want more simple explanations for complex topics, consider subscribing. Thanks for watching.